First of all, my thanks to our wonderful Vietnamese hosts who have been great, and my thanks to the conference organizers for many things. It's been a wonderful conference, but especially for including the session on the societal impacts of astrobiology. So I'm a research infrared astronomer. I specialize in star formation, but for 10 years I was the chairman of astronomy department at the Smithsonian's National Air and Space Museum in Washington, so the world's most popular museum, and that's when I began to get interested in questions like this. So this is the Kepler orrery. So there are over 4,200 extrasolar planets, most of them detected by transits. An amazing achievement. Most of them are confirmed, some of them are still candidates, but most candidates end up being confirmed. Many of these exoplanets have been characterized in radius, their orbital parameters, and so for the first time, we can place the assumptions about planets as hosts for life under the microscope of reality. So this Kepler, here's the solar system. For comparison, you can see the range of surface temperatures, sizes, orbital periods from, it gives you a feeling for the fantastic set of data that we have. So these amazing discoveries in the last 15 years or so have prompted lots of speculation. And in this session, I want to talk about how the discovery of exoplanets and their measurement impacts how likely we are to encounter intelligent life in the universe. And I argue it will be a long, long time. So, exoplanet discoveries have raised expectations. This is Klaatu. This is Klaatu. He's the alien from the day the Earth stood still, and he has come to save us. He brings advanced knowledge to the Earth. And A.A. Arison and others who have studied polls of popular opinion conclude one reason people are excited about ETI, extraterrestrial intelligent beings, is that they come from utopian societies, free of war, death, disease, other mid-20th century problems, and can help mankind overcome its problems. So you can chuckle at this quaint picture and at popular attitudes. But in fact, the scientists have jumped on board this bandwagon. So here are some recent news articles in the New York Times by scientists talking about aliens. This says them everywhere. Here are some, just this year, just the last few months, articles about life. It's a whole new book, The Aliens Are Coming, by Ben Miller, which I have not read. So scientists have embraced this idea of alien beings coming to Earth. And that's what I want to challenge. The public is being inundated with exotic science fiction at the expense of science. Is this healthy? Is it honest? Is it ethical? The evidence so far, it seems to me, suggests that we are not likely to encounter aliens for a long time, millennia, maybe even longer. So these are not new attitudes, they're rather traditional. Democritus, of course, talked about innumerable worlds, different sizes, irregular distances, some flourishing, others declining, being born and dying, colliding, Some have life, some don't. It's an old idea. Here's a kind of newer spin on it. This is from the textbook, Goldsmith and Owen, not so old, 93. Nothing in our theories for the origin and evolution of our sun is unique to the solar system. So they say 1 in every 2 planetary systems will have an Earth, to be conservative. You know, they explain an optimistic guesser would estimate, since we exist, almost every planetary system should have a planet of the right size. But they're going to be cautious, every 1 out of every 2. As for life, my favorite quote comes from Percival Lowell. So Percival Lowell is famous for hunting for Pluto, for his book on canals on Mars. And in his book on Mars, he writes, "From all we have learned of its constitution on the one hand or its distribution on the other, we know life to be as inevitable a phase of planetary evolution as is quartz or feldspar or nitrogenous soil. Each and all of them are only manifestations of chemical affinity." Well, probably we would all, none of us would accept that statement, I'm sure. Here's Mars. And today, every elementary school child knows there are no artificial canals on Mars, and there are no Martians either. Lowell's egregious error was the result of mixing meager evidence with preconceived faith, coupled with a fabulous extrapolation, in this case, that all physical environments must be the same and all sequences of events equally likely. So there are 2 clarifications as we go forward. The first is what I mean by life. The first, then, is only intelligent beings matter, capable of communicating. We may find life on Mars, primitive life, but unless a species is capable of conscious, independent thought and the ability to communicate with us, we are still alone, existentially alone, with no one to teach us, no one to learn from us, no one to share with, and if you like science fiction, no one to do battle. So intelligent life, for the purposes of my discussion, means life capable of communicating between the stars. To be alone, for all practical purposes, means to be without any communication or even the knowledge that the signal is coming for a long time. The principle of Copernican mediocrity was summarized by Goethe, and he put it aptly. No sooner was the Earth recognized as being round and self-contained than it was obligated to relinquish the colossal privilege of being at the center of the universe. So we were kicked out of the center of the universe. And after that, the opposite point of view came into play. We are mediocre. So here's a quote: "I can imagine an infinite number of worlds like the Earth, each with a Garden of Eden, all having Adam and Eves, half eat the fruit and half don't." So it's a statistical analysis. But half of infinity is infinity, so an infinite number of worlds will fall from grace, and there will be an infinite number of crucifixions. That's Giordano Bruno, who's burned at the stake for saying things like this. Here's another quote: "The Earth is the third of the planets circling the sun. They all move in elliptical orbits. They all have rotary motion and spots and so forth. Jupiter is flattened like our world. In short, there's every possible resemblance between the planets and the Earth. Is it rational to suppose the existence of living and thinking beings is confined to the earth, from what is such a privilege derived but the groveling minds of persons who can never rise above the object of their immediate sensation. So that's the director of the Paris Observatory, the famous astronomer Jerome Lalande. And in recent days, the same sentiment, Carl Sagan, we live on an insignificant planet, humdrum star, lost in a galaxy tucked away in a forgotten corner, in which there are far more galaxies than people. Well, that's true anyway. The human race is just chemical scum on a moderate-sized planet. We are so insignificant. That's Stephen Hawking. So all of these fine thinkers have made a big assumption. In contrast to biblical theologians who assumed that the earth and its inhabitants are special, these philosophers assumed we are totally commonplace and ordinary. But both sets are assumptions based on belief and not facts. And facts today are being investigated. And I argue that the truth appears to be somewhere in between. One last point, it's not only scientists who have embraced this notion of mediocrity. Here is Bishop Christer Stendal. It always seems to me, when God's world gets a little bigger, that I get a somewhat more true of my place and my smallness in that universe. So it's all in the spin. Even religious people have adopted a kind of opposite point of view, but it's not. My point is, this discussion is not necessarily a religious issue, even though people often tend to assume that if they win the lottery, it must have been a miracle. So it naturally comes up. So there are things we know in the search for ETI that were not known to Democritus or Percival Lowell. And that's the second important caveat, and that is relativity. The fastest that any signal travels is the finite speed of light. So even distances that are near us are relatively small. To be alone means to be without any communication for a long time. How long before we feel solitude? I choose 100 generations. This is the volume of space. This is a pretty good representation of the Milky Way. Here's the sun. This is a volume 100 generations in size. In that volume, which we can explore in 100 generations, so that's a long time, 1,000, 1,250 years each way. There are 30 million stars. So the question is, how likely is it that there are intelligent beings in these 30 million stars? We all are familiar with the Drake equation, which estimates these things. And at this wonderful meeting, we've heard from experts on many of the key issues. I just list a few of them here. Of course, that exoplanet needs to have a stable orbit around a stable star, stable for life, not only to form, but to evolve to be intelligent. So it needs to be in the habitable zone, which should be stable. The planet has to have the right size and mass to retain an atmosphere, not too big to have, so we have tectonic plates, a small eccentricity and obliquity, so the orbit should be suitable. And of course, chemical composition, including in the chemical composition radioactive elements, so that we can have radioactive elements in the core. What have we learned from exoplanets? Well, we saw it in that first Kepler orrery. The single most remarkable result is the exotic variety, completely opposite to what textbooks had been teaching. Sarah Seeger is an exoplanet astronomer at MIT down the street from me. Here's her take on it. These numbers change. At the time, she said fewer than 10 or 20% might be like our host star. And here's one example, Kepler 16b. It's a planet orbiting a double star at a distance of Venus. And of course, there are all of the biological uncertainties to form life, in addition to all of the astronomical ones. And in terms of evolutionary biology, of course, all of these people have emphasized how contingent life is and its evolution has been on the Earth. Not everyone, of course, agrees with them, but this is certainly one important point to keep in mind. Life's evolution is contingent, and geneticists, for example, have recently, or maybe not so recently, concluded from looking at DNA that it must have been the result of many fortuitous accidents. And I really enjoyed Jean-Pierre's comment in yesterday's presentation. Nothing is as we thought. There is diversity, there is contingency. Not long ago, the textbook by Zellick estimated 10 billion civilizations in our Milky Way, quite a lot. And my point is that we can't do much to increase these old estimates. But the results we have so far rather make things smaller, even much smaller. So while it's true that the physical processes operate everywhere, some sequence of events could be astronomically less likely to happen than others. The evolution of intelligent beings could certainly be such a sequence. The Misanthropic Principle, that's my name, expresses the idea that the multiplicity of possible environments in the cosmos are varied and uncooperative. So I picked it because the anthropic principle is the observation of fine-tuning that our universe seems so well suited. So as far as we are likely to know for a long time, 100 generations, if you want to know faster, 10 generations, well, your chances go down by a factor of 1,000 because the volume contains fewer stars, and if you want to increase your certainty, you just have to wait longer. So for a long time, we are probably not irrelevant or mediocre. We should respect this fact. People aren't happy when they hear that I tell them that. And it raises three dilemmas. The epistemological dilemma is, of course, not knowing about the existence of something doesn't mean it doesn't exist. How do we as scientists respond to people for whom the prospect of being alone, we're not going to get visited by Klaatu, without hope or salvation from a super intelligent species in heaven, is frightening. So how do we deal with that? There's the ethical dilemma. The Earth and humanity have problems. If we are simply a collection of evolved atoms, then these issues are of selfish concern but have no cosmic import. There's life elsewhere. But if, as far as we are likely to know, for a long time, maybe even forever, if we're alone, then maybe we are not so commonplace. Maybe the Earth is special and its life has cosmic value. So this brings great urgency to the need to protect the rare planet and its inhabitants. And of course, there's also a theological dilemma. If we might be unique, as far as we will know at least, then we have to consider the possibility that perhaps by quantum or other physical processes, we are part of some cosmic drive towards intelligence. So the universe is 13.8 billion years old. It has at last produced beings capable of comprehending it. It seems likely to me that we will be alone, no one to talk to, for hundreds of generations. The universe is expanding, even accelerating, so we will never be able to communicate with an infinite universe. So even if there is a meeting in the multiverse where I present a different talk, we're not going to know. It's philosophically amusing but irrelevant. Probably there's nobody nearby. probably we are not ordinary nor mediocre. We have responsibilities. Thanks.